Good afternoon, everyone. It's a little bit after 2 o'clock, so we'll go ahead and get started as some other folks come into the room and join us. Thanks very much for joining us today. My name is Carrie Riddle. I'm the Deputy Director with the CINA Center here at George Mason University. And we're really pleased to have you with us online today for a results briefing from one of our research teams at Hexordia, led by Cesar Quezada and Jessica Hyde, who are doing work on digital forensic investigations involving cryptocurrency wallets installed on mobile devices. For folks joining today from DHS or others who might be newer to CINA, I'll take a couple minutes to give a quick summary of what our center does. Excuse me. CINA stands for Criminal Investigations and Network Analysis. We are a DHS Center of Excellence funded by the Office of University Programs within DHS Science and Technology. And our mission is to fund and do research to help investigators better understand and disrupt network criminal activity, especially the activity of transnational organized crime, or CTOC. Our work is funded through a 10-year cooperative agreement that is funded annually by DHS-OUP, and we also have a basic ordering agreement that can support more sensitive or classified work from DHS components. Our research teams develop a variety of products like tools, technologies, and training materials. And the goal is to transition these to DHS and law enforcement agencies working in the space of CTOC. The team presenting today has produced a really great guide and some other knowledge products that can support investigators working with cryptocurrency. So for our law enforcement folks joining us today, if you're interested in using any of these research products that you hear about today, or if you'd like to transition these guides into training within your unit or component, we would be happy to facilitate that. We'll put some emails into the chat for you in just a moment. And our transition manager, Stephen Self, can coordinate with you on the details, or we can set up a time to meet to chat more about how to work with CINA. And so with that, I would like to introduce Cesar Quezada. He is the Director of Forensics at Hexordia, and he leads their digital forensics training and forensic services teams. They've recently finished the second phase of work on this project. The first phase of foundational research was led by Dr. Diana Summers, who is formerly at University of Alabama, but is now at DHS. So I want to make sure to acknowledge her initial work too. And Cesar's team took on a second phase to update the work with new cryptocurrencies and create the final products that they'll talk to you about during the presentation today. We will have some time for Q&A afterwards, so if folks have questions throughout, you can feel free to put those into the chat. Or after the main presentation, you can raise your hand to unmute and talk. So Cesar, we are really looking forward to hearing more about your work, and if you're ready, I will go ahead and hand the floor over to you.
Great, thank you very much. Thanks for having us here today. Let me go ahead and share my screen. So good afternoon, everybody. My name is Cesar Quezada. Like Carrie mentioned, I'm the Director of Forensics at Hexordia, and I'm excited to present this information to you today. I also have Jessica Hyde on the line as well. So we'll go ahead and get started. I'll let Jessica kick it off.
Thanks, Cesar. So excited to be here with you all today and to share the results from the phase 2 of the project on the digital forensic investigations of cryptocurrency wallets that you're going to find on mobile devices. So just so you know a little bit about us, Hexordia is a small business, small woman-owned, service-disabled veteran-owned small business located in Syracuse, New York, but also with offices in DC Metro. And we've been around actually now since June of 2021, and we focus only on digital forensics, but in that space, we work on research and development, training, and forensic services to government customers. All right, so what's this project about? Just like Carrie was saying, the goal was to provide a database of digital forensic artifacts of what you're going to find from cryptocurrency wallets from mobile devices. And in addition to that database, we also produced a guide for law enforcement agents on how to interact and seize those wallets from mobile devices when they're encountered, as well as a deep dive into those artifacts and how they're stored. And we as well wanted to make sure that we acknowledge the prior work by Dr. Diana Summers, apologies, and Rachel Salter, where they looked at a variety of apps for Apple and iOS. In the update to this, we looked at 20 different apps on iOS and Android using newer hardware, newer versions of the operating systems, but we also refreshed which applications we were looking at as the most prevalent ones in the field change from time to time. So the goal here today is really going to be to understand a lot about the basics of cryptocurrency, how to deal with the wallets, and most importantly, how that data is stored and encoded. And we're going to give a lot of examples of places where you'll see multiple levels of encoding. And this is why, in addition to just the database, that we produced a guide that walks through what those data structures are because of the nesting. And this really will give you some insights into these cryptocurrency wallets. What's cool about this presentation is Cesar's actually going to walk you through the different wallets on Android and iOS, exactly where the data is stored. And then we'll talk about potential next steps and how you can get access to these resources so you can use them in your investigations. With that, I'll kick back over to Cesar.
Thanks, Jessica. Okay, so for the introduction to cryptocurrency, what is cryptocurrency? It's just a type of digital or virtual currency that uses cryptography for security. Some of the key features that some of us may or may not be aware of is the decentralization. So cryptocurrencies operate on a decentralized network that's based on the blockchain technology. That means that not a single entity like a government or bank owns that, but it's distributed among a network of computers. And the blockchain, obviously, we've all heard about that. It's the underlying technology for the cryptocurrencies. It's a distributed ledger that records all transactions across a network of computers. And each block in the chain contains multiple transactions. And once recorded, the data can't be changed retroactively. It's also anonymous so that the transactions are recorded on the blockchain and they're linked to cryptographic addresses rather than personal information. So therefore, it makes it a little bit harder to trace. And for the distributed ledger, it's unlike traditional ledgers, which are managed by banks or some central institution. The distributed ledger in cryptocurrency is managed by, again, the network of computers or nodes that are distributed. So again, harder to track and trace. So for cryptocurrency in modern crime, obviously they are used to launder money because they allow for the transfer of value without the oversight of your traditional bank or financial institution. We've all heard about it in ransomware attacks, right? The attackers often demand that you send money to a cryptocurrency address because it's harder to track and trace where that money's going to. Darknet places often require the use of these cryptocurrency funds to buy things on the dark web. Scams and frauds, there's a lot of scams and fraud cases out there that are based around cryptocurrencies. The cryptocurrency is unregulated in a lot of ways, so it does make it easier for criminals to use and harder for law enforcement to track. And terrorist financing, North Korea is very well known for obtaining and trying to get cryptocurrencies because they are trying to fund they are terrorists and other organizations that are trying to harm the US. And of course, cybercrime. All common uses of cryptocurrency. So the problem for law enforcement is that it is a very rapid moving ecosystem. it evolves at a pace that is hard for government to keep up. The regulations are not in place to keep up with the way the cryptocurrency scene is evolving. And things like mixers or tumblers make it even harder for law enforcement to track exactly how those currencies are being funneled. Like I mentioned before, they're anonymous and they're really private due to the nature of how cryptocurrency is created. And cryptocurrency transactions can transcend national borders with ease, right? When you're sending money from the US to a foreign country, it's hard to trace that and track that. So now we're going to touch on a little bit about the types of cryptocurrency wallets. You have mobile wallets, and you can think of that as what we're going to talk about today, the mobile applications. They're stored on your smartphone. It allows somebody to store, send, receive cryptocurrency. There are also hardware wallets. These are wallets that are physical devices. They're specifically designed to store cryptocurrency private keys offline. They are meant to as a more secure means of storing your wallet information. And then there are web-based wallets. Some of these apps that we'll touch on today have a web app component. For example, MetaMask is a very common wallet that has a Chrome extension that you can use to, manage your funds in that wallet. So hot versus cold wallet. Hot, they are connected to the internet, highly accessible at any time. They're very convenient for users. So that's the type of wallets that we're going to be discussing today. Cold wallets are not connected to the internet and thus provide a higher level of security to the end user. Of course, it's less convenient because it's not connected to the internet. Everything online is a lot more convenient these days. An example of that would be like a ledger or a physical device, Ledger Nano. So today we'll be focusing on these wallets. These are the wallets that we analyzed for the project. We chose them based on the popularity and market share of where they are in the App Store. And also because some wallets that you may think are more popular may not have allowed access to something like a jailbroken device. They have jailbreak detections and therefore they would not be allowed in our testing, in our use cases. But a lot of these apps are cross-platform. Some of them have web apps. Some of them are obviously Android and iOS. We tried to pick a wide variety from each ecosystem to try to see where the data is stored. Before we jump into the wallet apps, I did want to point out the blog that Hexordia wrote, because this is very important. This was actually inspired by this project. When we're looking at mobile data structures, a lot of times some of us are used to looking at perhaps a JSON file or a text file or something that's very easy to read. Some of us look at SQLite databases, right? That's the first thing that's listed here. That's very common for as a data storage method for a mobile device. However, this blog and this graphic kind of shows you that you may come across a SQLite database with information, but inside one of those fields, it's going to be a binary P list. And in that binary P list will be some base64 encoded message. And then within that, once you decode that base64, you will be presented with another binary P list. So you have multiple levels of layers of decoding that you have to do. So it's not going to be a one size fits all easy extraction of the data. So what we're going to show you in a second is the output, but just understand that a lot of these outputs have gone through multiple iterations of decoding and stripping out of extra hex that's in the files. Okay, so we're going to go through the Android wallets now. So with Unstoppable, you can see what I've done is listed the artifact in the green bold, and then the file path for this exact artifact in the green bullet. So you can see here, we can see the wallet and then the cache file. You can see the wallet, it's highlighted in red, the type of coin, and this is a SQLite database. So this one's fairly common, fairly easy to take a look at and see. That is the wallet of the user and the coin that it's associated with. Here's more Unstoppable information. Here you can see the transaction. You can see where the transaction, who sent it, and then who it's going to. So Coinbase, you can see another address here. However, this is if you see the file path, it ends in 003.log. These are level DB files. This is a Google storage format. They kind of came up with this to be able to send and receive data very efficiently, very fast. It's a key value storage method that sends data in blocks, but a lot of your tools will not parse this out. It's one of the reasons why we have a data structures course to be able to teach folks how to get this information out. But you can see here a wallet address that you can tie to the user of that phone. Here we have more wallet address and transaction histories. This one is in a SQLite database, so this one's a little bit more user-friendly. Not as much decoding is required for this one. And then here's Coinbase again. You can see more HTML. This one again is a lot easier, more plain text, but you can see the app ID, the destination address that this is being sent to. So a lot of good artifacts for a sender, receiver, and it's going to vary amongst the apps. Here's another Coinbase artifacts, transaction hash. The transaction hash will allow you to take that transaction hash and then go to something like blockchainexplorer.com and be able to see that transaction, when it occurred, how much was being sent, and all that information, because again, all that information is kept on a decentralized ledger. Here we're moving to Zango. The Zango app on Android does keep track of the user information. So we have user address, we have the balance, the email here was verified. So with this app, you can much more definitively tell who the user was and you know what kind of information they used to use the app. We can also take a look of the registration date and the installation date of the app, which may be useful when you're timelining user actions on the device, right? You want to be able to say, hey, this app was installed at this time. They registered for an account at this time. You know, those things are very important to timelining. And then here are some Zango artifacts that you can see that they're sending money to an external customer. In this instance, that first line says MoonPay, right? So with this artifact, you can see that Zango is sending money to a MoonPay address. So that's important, because then you can start linking different apps, different wallets together and build a better picture for yourself. Here's eToro. There's some cookie information. There's another log file. That second file path is a log file, so that's another level DB. But you can see the user alias for logging in, and that's going to be the email address, the CLVB333. And then Guarda. Guarda is an app, so I would be very careful if you're using cryptocurrency and using Guarda, because here we can see seed phrases and private keys in plain text. And so what does that mean? If you have a seed phrase or a private key, what you can do is you can go to another wallet, use that seed phrase or a private key, and import that wallet as if it were your own. So basically, that's the key to owning that wallet, which is why it's been blacked out here. So that is being stored in plain text in your mobile forensic image. So more Guarda artifacts. You can see the creation time, the wallet address, the conversion rate, which may be important to you. Again, for timelining purposes, you know that at this date time, this coin was had a certain conversion rate. You know that it happened at that time. And then take note of this, the first file path here, this mmkv.default. So we have this first instance here for this app. So the mmkv is a efficient, small, mobile key value storage framework that's developed by WeChat. They use it for their WeChat app, obviously, and it's kind of like the LevelDB. They use it for fast data transfer, and you'll see that it's being used in a couple different applications because it is on GitHub. Anybody can use it and implement it in their own app. Case in point, we see Phantom here. So Phantom is another wallet, but it's also has some mmkv files in it. And here you can see the creation time, the wallet address, a bunch of different information associated with that wallet. MoonPay is another app. Here we see another LevelDB. This one is a 006.log. This one's been a little modified because we can see it in much more plain text, but we can see it email address, first and last name, a whole bunch of other data about the user of this app. So a lot of good artifacts for you to use. Rainbow Wallet, another mmkv. Here we can see the wallet address of the user. Here we have Rainbow. The top one is a JSON file with an install date and some geographic location. But we also have wallet addresses and in the bottom screenshots. And those are in SQLite. So what we found is a lot of different wallet addresses that are spread throughout a forensic image just based on one app. Here's MetaMask with a bunch of different cached web data. Perhaps you have a wallet address that was used at the time of the arrest, and then you can go back in the cached web addresses and see that perhaps they use a different address when you're doing investigation, because we can see this. The bottom one has a few different wallet addresses. And then the 005.ldb, we have more LevelDB with additional information. And then to the right, we can see additional information that's more plain text in nature. And here we have OKX, not much information, but we do get a wallet address. And Gemini, same thing, not much information. So if you were going to use a cryptocurrency app, OKX or Gemini may be good ones to use because they're not saving much on device. Clearly, they are doing everything over the net. So for iOS wallets, so first one up is Phantom. So Phantoms This one is a more iOS artifact. When we're talking about KTX files, if you look at the extension of these files, so KTX snapshots are what was last used by the user. So when an app is swiped away or in the background, you'll usually get a kind of like a thumbnail KTX format so that it's easier for the operating system to present that back to you. But these are good sources of information when you're looking for, when you're doing an investigation, because they will contain data that's probably relevant to you. In the instance of Phantom, here you can see the wallpaper on the left. So you know that you have a cryptocurrency app on the device at some point. And then the other one on the right is a wallet account with the amount in it. If you're interested in KTX files, there are some good blogs by Alexis Brignoni and Geraldine Bly. And then KTX files are not very friendly on Windows. So if you want to convert those to like, let's say a PNG or some JPEG file that's more easily viewable on a Windows computer, I would suggest Yogesh Khatri's script. He recently updated it, so all you have to do is click that KTX file and drag it over the executable, and then it'll automatically spit out a JPEG file. So here we have Phantom. We have more sender-receiver information, the amount, the transaction hash, the date time, and the arrow's pointing to a picture on the right, and that picture is from Blockchain Explorer. So I mentioned Blockchain Explorer previously, but if you take that transaction hash and you put it in Blockchain Explorer, you'll get what that right arrow is pointing to. You'll get the address from and then the to, because it's recording all that information and it's there for you if you have the transaction hash. All right, here you see another database that's a little easier to read. You can see the wallet address and the amount. Now the amount is, it looks like it's a lot, but you see that decimals right above it, it says 18. So the way you read that is you need a total of 18 digits to the right of that decimal. So you have a big amount here, but you need 18 complete digits. So you need a lot of leading zeros, and then you add that amount. So it's not as much as we think, just so that you're aware. Okay, so Phantom, continuing on, we have more wallet addresses and account ID in different SQLite databases and just databases overall. Moving on to Uniswap, we have more wallet addresses. This was a receiving address for Phantom Wallet. So in this instance, the app is recording the address the money is being sent to. So that's just something to be aware about. And then here's the first instance of this file called breadcrumbs.1.state. So, and also in the file path on the right-hand side, you can see io.sentry. So io.sentry is also another GitHub repository. And you can see that it is built for real-time crash reporting for your web apps, mobile apps, and games, right? So a lot of these developers are using different resources. Obviously, the Sentry is a popular one because we've come across it a couple of times in these cryptocurrency wallets. I've only really come across one forensic blog post that mentions a breadcrumbs file, but again, you'll see different breadcrumbs entries for different wallet apps coming up. Again, Uniswap using more breadcrumbs files. We have more wallet addresses, more date times. And this one is a blob file, you know, poor blob. Blobs used to be very cumbersome, but now We are moving on to level DB and breadcrumbs and MMKBs these days. They are the problem child now. Okay, moving on to SafePal. You can see transaction hashes. Again, we can look those up on Blockchain Explorer and verify what the addresses are and the time that they occurred, all pertinent information pertaining to that transaction. Here's another KTX file that shows you a snapshot of a wallet. This snapshot shows you the value of a few coins at a particular time. It doesn't really show you any value in that user's wallet. But if you wanted to know, like, let's say when this app was being used, you could actually go, see when Bitcoin was at this price and Ethereum was at this price, and then kind of do a timeline just on the open web and work backwards and see exactly when they lined up to when this screenshot was taken. Of course, it's not going to be definitive, but at least you have some kind of frame of reference. So Exodus, we can see a transaction ID in JSON with the amount and type and date time. And there you can see the coin amount. You can see the 0 dot and then the leading zeros, right? So that's kind of what you're looking at from that previous slide that I explained. Here we can see Exodus with wallet address that the money is being sent to and a timestamp. And then this screenshot here, this artifact is not it's not the amounts that was in a user's wallet, but this is important. These are exchange rates at a certain time, right? Kind of like with that screenshot with trying to do a timelining. You kind of know when this artifact was created based on the exchange rates at a certain time. We know cryptocurrency is always fluctuating, so it just gives you a better frame of reference for when things are occurring. And then here's more wallet addresses from MetaMask. This shows more wallet addresses for the user. And MetaMask is a fairly popular wallet because of its Chrome extension. When we were doing our testing, we could do a transaction on the phone and we can see it immediately sync with the Chrome extension. So if you have a MetaMask on the device, you probably have MetaMask on a computer somewhere in a Chrome extension. And here's more breadcrumbs files. All these are breadcrumb files, right? So now we have breadcrumbs 1.state. We have a previous.breadcrumbs.2.state and a previous.breadcrumbs.1.state. So there's more artifacts being left by this crash report GitHub page. And with Bither, we have more KTX files just to showing that the wallet was being used. We have the balance and then the coin type. And this one looks similar to the previous slide, and it has very similar information, but it is a different artifact. Just again, these artifacts and copies of the artifacts are being left all over your forensic image. So if you find something in one place, there's probably a lot of other locations to look at. And here we have additional addresses. We have address and transaction hashes. And here we have Coinbase. Again, this one's on the iOS side. So we have the file path for the SQLite database for the transactions. And Coinbase has geolocation checkers in place. So I'm certain that's just to make sure that you're using their app in an authorized location. You can see that it says permitted true. So I was in the US, obviously. And then on the right-hand side here, you can see that it is checking for a jailbreak. So our test device, in order to do a full file system, we did jailbreak the device to be able to get that full file system image. And Coinbase is one of those apps that will say, hey, your device is jailbroken, it's not secure. You just hit OK and you continue using it. But some of these apps will not let you proceed. And then here's a snapshot of the supported coins for Coinbase, the coins that they support. Not really user specific, but important, right? Because it narrows down the coins that you're looking for Coinbase. And then here's another KTX file of a snapshot of the app along with the value in the wallet. So again, if you're working on the iOS side of the house, keep an eye out for those KTX snapshot files. And then we come back to Guarda. Again, Guarda, just like on Android, we see the same type of thing in iOS. They're using, or they're storing their seed phrases and their private keys in plain text. That means as a forensic examiner, you can see those in plain text. And it's not very secure for that end user. So we can see here the wallet addresses, the balance, how much was sent, transaction hashes, all good information to identify the transactions that occurred within the app and what was being done. Guarda is probably one of the most, the more loud apps out there, recording everything and saving everything on device. With MoonPay, we have the coin and then the wallet addresses. So the top one's Bitcoin, the bottom one's Ethereum. And again, just aiding in your investigations, we have coin and their pricing at certain date times. And we have more wallet addresses within MoonPay. And MoonPay does store some user data. You have the created, their birthday, their email address, and then first and last name, and the location, the general location where they're located. And then finally, we have MoonPay and KTX files that stored a recovery phrase, right? Again, using these 12 words here, you could use all those words and import it to a new wallet and take ownership of that wallet. So the fact that you have that in a KTX file is very troublesome, but that's the nature of digital forensics, right? You just have to be able to do your investigation and look for artifacts in many different places because it's not going to be in one general location. And with that, I will turn it over to Jessica.
So really, to me, the synopsis of all of that is each one of these wallets has unique storage. Every single one is different. They are using not only a variety of nested data structures, including things like level DBs, NP-less, and SQLite databases, but we're also seeing these newer data structures that seem to be unique or used less regularly by other apps that are coming off GitHub, such as IOSentry and MMKV, which is really requiring examiners to be able to manually analyze and go deep. But the great thing is, at least for these 20 extraordinarily prolific apps, these hot apps, we've put together this database. So let's show you a little bit of what you can get if you go to the site, so you can actually use the resources based on this research today. So the database really is a document that provides you, for each wallet, the path locations where the data is, the type of artifact you see there, and then information about how to deal with it. While you'll see some say things like view in HTML format, like row 6 in the top, you will see, however, for this one that happens to be using breadcrumbs, if you look in breadcrumbs 1.state for the wallet address, you have to view it as a JSON in Notepad++, because trying to view that JSON in tools like Axiom or Rabbit Hole actually don't parse and allow you to see it. So we really focused on telling you how you could get to that data. For example, that CacheDB this is for Uniswap in row 1, is telling you that you're going to take that database, you're going to go to the blob table for request object, you've got to take that blob out, reparse it as a plist, and then once you reparse it as a plist, that data you're now going to go to the CFURL string specifically and then view that string as JSON. So we kind of give you those steps to walk through in the database, but in addition, there is a full report that walks through each one of these apps that Cesar was talking about, and there's a page there with screenshots that tell you where to parse that data from. Now, parsing the data is only half of the problem. In addition to parsing the data from the mobile phone from a forensics perspective, we often need to seize the data from those wallets and move it away right away. So there is an easy to use seizure guide for law enforcement agencies. And in that seizure guide, there is a step-by-step with photos and screenshots for each one of these 20 wallets as to how to seize the data from them. So we tried to provide as much detail and give you a usable guide as possible. So a usable, not only the database of where these artifacts can be found, but a usable guide for seizure and a usable guide for forensic analysis. And so you can find all these results on the CINA website, all 3 products, the cryptocurrency wallet report, which is really that deep walkthrough of where each artifact is on each wallet, the wallet seizure guide, which is great for printing out and having in the field. So when you encounter these wallets on a mobile device, you can quickly seize that data and get it off into your agency's approved accounts. And then finally, that compiled findings of where all those artifacts is in that quick reference document database structure. And we'll be sure to put that link in the, and thank you, Carrie, for putting that link right in the chat. There is a lot more that we could do from this. As we mentioned, a lot of these data structures are complex and nested, and that gives us a couple of opportunities if these are things that you would want to see in future work. That could include creating a tool to parse the data from these wallets in an open source framework, think a Leap project type way, where you'd have a GUI, you'd be able to load in your image and get the parsed wallet results. We could provide some training on these particular applications involving the different data structures that are encountered, where these locations are, how to do both the seizure side as well as the analysis side, and really including things that I haven't seen in any other training. Whereas we teach data structures and how to deal with XML, JSON, ABX, etc., we don't in our courses teach IO Sentry or MMKV. So that could be something that's crypto wallet specific, where a class could be built to help people know how to deal with these, both from an analysis and a seizure perspective. And then, of course, as we mentioned in phase 2, we had to start with all new wallets and all new data because of how rapidly they're changing. And there are plenty more wallets that we would be happy to look at, but we don't know what you all need. CINA doesn't know what you all need. So please, I know Carrie shared the information about how to reach out to CINA. So please share the things that your agency could need or use, because these resources are now available to you, and we hope that you'll find them valuable. And with that, we'll turn it over to questions.
Excellent. Hey, thank you very much, Cesar and Jessica. Really great presentation. You shared some really good tactical points that we're sure folks can take away and immediately apply. And we'll have the recording posted online in a few days too at the same link we shared in the chat so folks can refer back to it. But we really appreciate all of your team's work on this and the training guides. We think that everything's going to be really useful, and we're looking forward to getting those materials into folks' hands. So yeah,